All right. Thank you, Bernadine, and thank you all. Welcome back to class, and so happy to see you. Happy to see you all attending class today. Today is not supposed to be a class day, but we are behind time preparing for the examination. And so we have to do what we can to catch up and take the exam on time. So that is why we are here. And we thank you all for making the time to join this class. It's going to be a wonderful session. We are going to achieve a lot today. And since we started, we've been covering a lot. We've been learning a lot. If you are not following the lessons, then please, you are missing out so much. You are missing out on a whole lot. Put yourself into this, immerse yourself into this training. Make sure you learn, not just for the examination, but for your career, because all that we are learning will upgrade your skills and enhance your abilities to do well and to be able to learn more and advance in tech. If you have a dream for tech, if you have a future in tech, if you have a career in tech, and even if you live in the modern world and you want to be a digital literate, then this course is just the best for you. Go through it, get certified, and upgrade yourself. This will help you to be able to be a better analyst, be a better engineer, be a better developer, be a better cybersecurity professional, be a better tech professional. So let's keep learning. Let's learn hard. So welcome once again. Great to see you all. Let me see some of the people in class. Let me just check some of the names. I hope you are doing very, very well. I can see Yvonne. Wow, great to see you. I can see Weldon, Lucretia, Adewumi. Okay. I can see Jael. Great to see you. Great to see you. God willing, next week by this time, we are going to be hearing great news. So the first batch doing well, passing, getting certified, and telling you about their experiences. I mean, those who will take theirs next. So let's all prepare. Let's go through it. You see, this series of training we are having, we are actually exploring the real AWS services and we are learning the right things. Okay, we are learning really, really well. And so let's go through all the videos and get all the knowledge we can get from this. Yeah. So today is day 11, and today we want to cover a very, very important storage service. Very, very important storage service. And it is called EFS. EFS, Amazon EFS. And we've covered EBS and S3. We need to cover EFS because it is a very, very important service, very vital for this examination. So let's get ready for that. And before that, I'm going to play a short clip about EBS so that we refresh our memories on EBS. We'll be taking a test on EBS after this lesson. So let's watch this short clip, refresh our memories, and we'll get started with EFS. So let me share my screen and we'll watch this clip.
Amazon Elastic Block Store, also known as EBS, provides persistent block storage for use with Amazon EC2 instances that can scale and adapt to meet your performance requirements. Tightly integrated with EC2 instances, Amazon EBS provides high-performance, low-latency block storage with 4 different volume types to meet the needs of any workload. SSD-backed volume types deliver low latency and the highest IOPS, while HDD-backed volume types deliver the highest throughput, with 2 options for each type, depending on your performance and budget needs. SSD-backed volumes are best for boot volumes or transactional workloads, like enterprise applications, relational databases, and NoSQL databases. HDD-backed volumes are best for applications producing streaming I/O, including big data applications, data warehousing applications, and log processing applications, or for staging application-level backups before snapshotting to Amazon S3. For any type, you'll have consistent performance and be able to connect different volume types to a single EC2 instance for applications whose components have different performance profiles. Because you can modify live volumes without affecting performance or availability, you can adapt easily when your needs change. And point-in-time snapshots enable efficient backup, recovery, archiving, and creating new EC2 instances, all stored in Amazon S3, which has 11 nines of durability. With encryption in flight and at rest, Amazon EBS adheres to the most stringent compliance standards and regulations. Plus, Amazon CloudWatch can provide alerts when you need to adjust capacity or volumes. Consider it for your next high-performance application deployment in the AWS cloud. Find out more at aws.amazon.com/EBS.
All right. So now let's get into the lesson for today. Since we started, we've been going over the AWS services. We talked about when AWS was launched. If a question is asked about the launch date of AWS, I'm sure no one here will get a wrong answer. Because if you get a wrong answer, I'll come to your house. You'll see me in your house. We talked about the compute services. We talked about EC2, Lambda, Elastic Beanstalk, ECS, EKS, and we have Lightsail. We may touch on Lightsail briefly, but that will be confirmed later. On the storage services, we've covered S3, we've covered EBS, we've covered Glacier, and today we want to talk about EFS. These are the core services under storage required for the examination, and we will brush on these ones as well before we end everything. We also have database services like RDS, DynamoDB, Aurora, Redshift, DocumentDB. Going over all these things, learning these services, and knowing how these technologies are available for use and available to you for your projects, for your company, really, really enlightens you. And as you understand how to use these, you are really going to operate at a top level, at a very, very top level. We also have network services like VPC, Route 53, CloudFront, Direct Connect, API Gateway. Management like CloudWatch, CloudTrail, Config, Systems Manager, and organizations. Talking about the storage services, we've covered most of them, and today we want to talk about EFS. If you are with me in the class, please type EFS in the chat for me. EFS, Amazon EFS. All right, EFS. So welcome, Ato. Welcome, Norbert, Wildam, Adewumi, Franklin, Lucretia, Louisa, Guguletu, Yvonne, Israel, Frank, Adewumi. Wonderful. EFS. Now, EFS stands for Elastic File System. Please put that in the chat for me. Elastic File System. Elastic File System. So we are going to explore this particular service and understand it, because AWS really enhances and emphasizes this particular service, and it is one of the storage services that is highly used and really, really required for the examination. Before we went into storage services, we talked about types of storage. We talked about file storage. We talked about block storage. We talked about object storage. And we related object storage to S3. We related block storage to EBS. And for file storage, we learned that it uses a file system and it follows a hierarchical structure with directories and files in the structure to store data. And we learned and we mentioned that AWS has a service for file storage. And this service for file storage, which uses file systems, is called Elastic File System. So this is the name of the service, EFS, among the AWS services, and it is a fully managed, and very soon we will understand what fully managed is. You know, when you look at this, it says that EFS, first of all, what we know about it is that it is the file storage service of AWS. EBS is the block storage service of AWS, and S3 is the object storage service of AWS. So we know something about it already. But what we are going to learn today is that it is fully managed. Now, when we say something is fully managed in AWS, what it means is that AWS manages the service on your behalf, or AWS is in charge of the management on your behalf. This means that it uses the concept of abstraction, a high-level abstraction. So you just set up configurations, you just do your settings, and all the infrastructure involved is managed by AWS. Similar to the concept of serverless computing, but when we say fully managed, it simply means it is managed by AWS. It is also serverless. So if you look at this particular service, it has two features that makes it very, very easy to use. Serverless, we already understand serverless. And once we say serverless, it is more about compute services because there's a server involved, okay? So once we say serverless, we are talking about a compute service that AWS abstract away all the complexities and all the provisioning and all the management. And you only, like Lambda, just upload your code and do a few settings, and AWS manages it for you. With serverless, you don't configure anything. You don't even see the underlying infrastructure. Everything is taken care for you. So this is very similar to fully managed. But when we say fully managed, it does not necessarily mean it is a compute service. It can be a different type of service. But when you hear fully managed, it means AWS fully manages it. Now, in the context of compute services, is fully managed the same as serverless? They are kind of 80% the same. But there are some compute services that are fully managed but not serverless, like Elastic Beanstalk. With Elastic Beanstalk, it is fully managed, but you still have access to the servers. You still configure the servers. You can still make changes to the servers. You can still adjust all the resources and the services they give you. So that is what it means. So once you understand fully managed, it simply means it is managed by AWS fully. All right. So this EFS is fully managed. It is also serverless, and it is file storage. So when we talk about file storage, you can see that this is the main file storage service of AWS. It is file storage. All right, let me start it again. So Amazon Elastic File System, or EFS, is a fully managed serverless file storage service that provides scalable and shared file storage for EC2 instances and other AWS services. That is what it is, and that is what it does. Wait a minute. Didn't we say that EBS is the persistent storage for EC2? All right. Yes, we did. What we are saying now is that EFS is also storage and can be connected to EC2 as well and other AWS services, but does not work like the way EBS works, and we'll find out very soon. Unlike block storage like EBS, which is optimized for high performance, single instant access, EFS provides a scalable, high availability solution for specific workloads that require multiple servers to access the same file system concurrently. All right, let me explain this. So, like we studied yesterday, EBS, Elastic Block Store, is the persistent storage or persistent block storage service for EC2 instances. They function like hard drives that are virtually connected to EC2 instances. That is wonderful. We are going to look at certain situations where EC2 will also need a file storage service. And this will let us understand how EBS and EFS work for EC2. Now, from this text, it says that EBS is optimized for high performance. So, for normal high performance applications, EBS is the storage, and in general, EBS is the storage for EC2. And over here, we are seeing something highlighted as single instance access. Single instance access. What this means is that EBS is by default designed for single EC2 instances. And so by default, although yesterday we mentioned a feature called multi-attach, but by default, EBS is connected to single EC2 instances. But when it comes to EFS, EFS provides scalable, meaning it can scale up and scale down automatically, high availability solution for very, very specific workloads that require multiple servers. So over here, the keyword here is multiple servers. What does that mean? Multiple instances to access the same file system concurrently. So this is telling us something. Let's read on. EFS enables multiple EC2 instances to access the same file systems concurrently. All right. There are situations where not a single EC2 getting a storage, but multiple EC2 instances accessing the same storage space concurrently. making EFS ideal for special workloads that requires shared data or file storage with a traditional hierarchical structure. All right. This means that there are certain workloads that requires shared data with the file system structure. And in this, or with this particular workloads, it usually happens when multiple EC2 instances wants to access the same storage space or the same data at the same time with the file system structure. EFS is ideal for applications like web hosting, content management, and data sharing, where shared file access is more important than ultra-low latency performance. All right. So over here, what we are saying is that there are certain situations in the cloud where file sharing or shared file access is more important than high-speed performance. And so in situations where multiple servers or multiple EC2 instances wants to share the same file or wants to share the same data, like in the context of web hosting, content management, and data sharing, EFS is the service for that specific type of workload. EFS is specifically built for shared access. So this is built for shared access. What does this mean? If you look at a web server, a web server has a storage space where uploaded. And that storage space becomes a central data location where thousands of computers request for the website files. And so whenever you visit a website, you are requesting for the files from the server. And if you have built a website before, you know that websites is just made up of files. And so with your laptop, when you visit the website, you are actually requesting data from the server. So that particular server is able to share the website files with you, starting with the home page and its associated images and resources. So on your system, you are able to browse. On your phone, you are able to browse. And what you don't see is that 1,000 other people are also visiting the website at the same time, and the same web server is serving everyone at the same time. You are not the only one on the server. You are not the only one on YouTube right now. Millions of people are on YouTube now as we speak. Wait a minute. So if YouTube, let's assume is served by a server, it means that the server is actually serving and that is why it is called a server. It serves data. It is actually serving all the users who are currently on this particular website. Okay, so to the user doesn't think in terms of server. The user thinks in terms of what they are getting on the website. But technically, they are requesting and communicating with the server directly. So this particular server is designed for shared access. Several computers are accessing data from it at the same time. Several computers are accessing data from it. Several computers are making requests to it at the very, very same time. EFS is like that. EFS is designed for shared access where multiple EC2 instances needs to retrieve data from a single location at the same time. Just like your hosting server allowing multiple visitors to retrieve data at the same time. So when you think about this, this is different from the system itself, the EC2 instance itself having its own storage. This is different from the EC2 needing storage or its own workload. This is designed for situations where multiple EC2 needs data from a single source. Let me explain it this way. Yesterday, we compared the idea of instant store and persistent storage with your personal computer having its RAM and hard drive. And we said EBS is the hard drive in comparison. The ephemeral storage or the instant store is the RAM in comparison. Does that mean that in a network environment, you don't connect to another data source? Is that what it means? That in a network environment, your computer doesn't need data from another server or from another system? As a matter of fact, when you connect to a network, even though you have storage on your computer, you are still able to connect to the network and request data from a central data source. This is a common concept in computer networking. Also, when you visit a website, your computer is connected to a server and retrieving data from an external source. This is a different concept from your computer having storage. So what we are saying is that EFS is built as a central shared access storage. And it is different from single instance storage like EBS, which has ultra low latency and high transactional performance. EFS is designed to scale automatically as your storage needs grow, and is ideal for workloads requiring concurrent access by multiple EC2 instances. I'm going to play a short clip about EFS, and after that, we will talk more about the differences between EFS and AWS. So let me share my screen again, and we'll watch this short video.
Amazon EFS is a cloud-native data store that provides simple, scalable, elastic shared file storage for Linux-based business applications. It can grow to petabytes while delivering consistent low latencies and high levels of throughput. And it's fully managed, so you don't have to worry about ongoing maintenance. Amazon EFS is easy to set up. Simply use the AWS Management Console, API, or command line interface to create a file system and make it available to one or more Amazon VPCs. Your EC2 instances can securely then mount your file system to store and access data. You can also mount on-premises servers to EFS using AWS Direct Connect or AWS VPN, making it easy to migrate data to EFS, enable cloud bursting, or back up your on-premises data to EFS. EFS file systems are elastic and automatically grow and shrink as you add and remove files. You can choose between two performance modes so that you can tailor your file system performance to your application needs. Throughput for a file system scales automatically as capacity grows. For workloads with high throughput requirements and low capacity needs, throughput can be provisioned independent of capacity. For less frequently accessed data, you can configure EFS to store data in a cost-optimized infrequent access storage class. Amazon EFS works with the tools and applications you already use. It is designed for high availability and durability, storing your data redundantly across multiple availability zones. With EFS, you always have the capacity you need, when you need it, without having to provision storage in advance. Pay for only what you use with no minimum fees or setup costs. It eliminates storage administration tasks, so you can focus on more crucial business. To get started, visit aws.amazon.com/EFS and create your first file system in just a few clicks.
All right, so let's continue. How EFS differs from EBS. Let's talk about use case when it comes to EC2 instances, because they are all storage services. EBS provides block storage and EFS provides file storage. Let's look at EFS. EFS is designed for shared storage where multiple EC2 instances need to access the same files simultaneously. It is great for use cases such as web servers, content management systems, or applications that require a common data source across a distributed system. Let's look at EBS. EBS is primarily used as a single instance, high performance block storage for EC2. It is optimized for use cases like databases or transactional systems where low latency and high IOPS are critical. So with this, when it comes to EC2, what this means is that primarily EBS is the single instance storage for EC2. And EBS is a shared storage for EC2. It's a shared storage for EC2. Specifically for use cases where multiple EC2s needs a shared data source. where the data source should also have a file system structure or a hierarchical structure. Now, within the cloud, you have to understand that this is a multi-networked environment, and how applications are connected to data sources are sometimes dynamic and a little complex. For now, what we need to take from this particular lesson or this service is that EFS is a managed file storage system from AWS. It is used with EC2 instances in situations where multiple EC2 instances require a central or shared data source, like in web server for web hosting, or CMS, content management, and special applications that require a common data source across distributed systems. In terms of performance, EFS provides scalable performance. This means that it automatically scales. It is also elastic, but with a higher latency compared to EBS. When we say higher latency, what this means is that this is slower than EBS. But it is suitable for applications that prioritize shared access over speed. And so there are applications that require data to be shared across multiple instances. And that particular VPC, we'll be talking about virtual private cloud, or that particular network and network attached storage, we'll be looking at that as well, or file sharing is more important to the application than speed. What EFS does is unique in a way that EBS cannot do. And EBS is ideal for applications requiring low latency, high speed access, such as those involving real-time data processing and high performance databases. So let's picture it in this way. EBS is designed as storage volume for EC2, while EFS is designed as a storage access for multiple EC2s. When we studied about EBS, we learned about the concept of multi-attach, where the EBS can be attached to multiple EC2 instances. So how is that different from what EFS does? Let's look at the concept of single attach and multi-attach. Now, while EBS is primarily designed for single instance attachment, it offers a multi-attach feature for specific scenarios. Single attach, so by default, an EBS volume can only be attached to one EC2 instance at a time by default. This means that EBS was created as primary storage or single storage for EC2. This ensures consistency and reliable performance for most workloads running on the EC2. So why is it that we also have multi-attach with EBS? There are certain volume types on EBS, such as the IO1, IO2. If you remember yesterday's lesson, we talked about some volume types. There are some specific volume types that supports multi-attach. So the multi-attach feature is not supported by all EBS volumes, but the IO1, IO2, those particular volumes support multi-attach, allowing multiple EC2 instances in the same AZ to access the same volume simultaneously. However, this requires the application to handle data consistently, as EBS does not manage it in this mode. Multi-attach is designed for clustered or distributed applications like specialized databases. Key features of EFS. Now, EFS is shared file storage for EC2 instances. So this is the main understanding of EFS. And according to AWS, there is a great need for shared file storage. And so for single persistent storage for EC2, that is okay, that is normal, but there is a great need for shared file storage in AWS. So which AWS service provides shared file storage for EC2 instances, where multiple EC2 instances need to retrieve data from a single source? There is a great need for that in the networked environment of AWS. And that need is served by EFS. And since EFS was launched, EFS has been instrumental to solving a lot of cloud operational problems. And for shared environments like that, we require file system storage or file storage for that solution. So AWS provides object storage solution with S3. AWS provides block storage solution with EBS. And AWS also provides file storage, specifically shared file storage solutions, EFS. It is scalable and automatic performance adjustments. This means that it can scale by itself automatically. It is elastic. So once you get elastic in AWS, it means it can scale, it can grow, and can reduce by itself. Just like a rubber band, it is automatic. If you hear elastic, it means it can stretch when the need requires it. So when multiple servers are requesting data from EFS and it needs to scale, it can scale up or scale down. It is also fully managed, which means there's no need for manual management. And so keep the idea of fully managed and serverless in mind. And EFS is also serverless. Data is stored across multiple availability zones to ensure high availability and durability. So we learned that with S3. S3 provides durability, 11 nines durability, and high availability. EFS also does the same, or also provides high availability and durability. Since the cloud operates with a network or in a networked environment, especially in the case of EFS, it operates in a virtual private cloud environment, a highly networked environment. The file system it uses is called NFS. Please put that in the chat for me. NFS. So the file systems we are used to already are Windows file systems like NTFS, like FAT32, like exFAT. We are used to all of that. We have Linux file systems like ext4, which with time we will get into. Right now, we are talking about a cloud network environment, and we are hearing of a new file system called NFS. Wow. What does NTFS stands for? NTFS. I'm sure you know NTFS. What does it stand for? NTFS. NTFS stands for New Technology File System. Okay. You have to understand that this file system operates in Windows environments. And we have studied about file system to understand how file systems work and how important they are and how they organize data. Now, in AWS, we have a file system called NFS, which is called Network File System. So instead of NTFS, this one is NFS, and this one is a file system for a cloud network environment. So you see the way network. This means that multiple connections take place. That is why with EFS, it is designed for multi-access. And this NFS is what allows multi-EC2 instances to access the same data, concurrently. So when it comes to a situation where multiple EC2 instances need data from an external source, which solution in AWS can provide that? EBS is not ideal because EBS was not designed for that type of scenario. We have learned that we have some EBS volume types that can allow multiple EC2 to be attached to the same EBS volume. But even with that, this is in a limited environment, or this is very limited. Whereas EFS was actually designed for multi-sharing environment or for network sharing environment. And so sometimes we refer to the EFS storage as a NAS. Please type NAS in the chat for me. NAS. NAS. However you heard it, please type it. Let me see. NAS, that's it. Prosper got it. Now, a NAS is an idea of storage for network environment. Okay, a NAS is a special storage designed for network environment. One time ago, I told you about one TV station that I worked with, where every day journalists record a lot of video footages day by day. In a day, we can have more than 30 gigabytes of data that we have to store. Now, one person's computer cannot do that work. As a matter of fact, even if it can do that work, it cannot continue working for 1 month. Meanwhile, we will need our archives. We will need footages from several months ago. We don't have to destroy our data. And so for such a company, we need to design a storage solution that will allow all the journalists to have a central repository for their footages. And so once they come back from the field and they come back with their footages, they need to store them on a server or a central storage source. And this particular storage source or server was designed purposely for storage purposes, okay? And then they all need to be able to have access to that storage source. And so we created a network and connected all the computers to that central storage repository. So you don't have to store the data on your PC. That storage repository has a space of several hundred terabytes heading to a petabyte. This means I can store data for more than 3 years. And so we store our data over there, and every journalist or everyone in the company who has access can access that storage source. Because of the network that has been done. When we talk about computer networking, it's about connecting multiple computers to each other. And we have designs where they all have a central connection point, like a server and a storage source sometimes. So because this particular storage is connected to a network environment, we call this a network attached storage, NAS. We call it a NAS. That is why I asked you to put NAS. So NAS stands for Network Attached Storage. Network Attached Storage. So it is a central storage for a network. Apart from a NAS, we also have a SAN. Please type SAN in the chat for me. Just reverse the NAS. So in computer networking, when it comes to storage or storing within a network, we have a NAS and we have a SAN. A SAN stands for Storage Area Network, just like we have local area network and we have wide area network. I'm sure you've heard that. We also have storage area network, SAN. I'm not going to get into details because of time, but it is similar to this same concept of designing a network for a storage purpose and having storage or central storage for the computers that connect to the network. So EFS is designed as a NAS for cloud environment where EC2 instances connect to for data. Use cases, web hosting, multiple EC2 instances serving the same web application files from a shared file system. So multiple EC2 instances serving the same web application from a shared file system. Let me give you one example here. When you build an application, you can deploy the application to become an installer or a desktop application with a setup. And we've all installed applications with a setup before. How do we do it? We run the setup or the installer on our personal computers, and then we click next and next and next and next, and then finish. Then we install it, right? We all do that. Now, one issue with that kind of installation or that kind of deployment is that any computer that wants to run the application needs the setup or needs to install it. Everyone has to install it to use it. And so until you get everyone to specifically install it, if you don't have it installed, you can't use it. That is very common. We all know that, right? Okay. We also have certain applications that, because we don't want the idea of everyone needing to install it or the application being restricted to a computer, we decide to deploy the application online. So we put the application online, whether on a web hosting server or in a specialized cloud environment like AWS. And so if you need the application, you don't have to install it. You only need a computer connected to the internet and you use the application. Let me ask you a question. If you build an app and you want everyone to use it. You want it to become very popular and very, very easy to install, very, very easy to use. Would you prefer an app that everyone needs to install it on their PC to be able to use it, and without their PC, they can't have access? Or you would want an app that is installed at one location and everyone can access it? Okay. Now, think about the work involved. Let's say you are even an IT person and you are creating an app for your company. Let's assume your company has 5 branches and all the workers need to use this application. Okay. All the workers need to use this application. Would you want to go around all the branches installing for every worker on their computers one by one after going through the work of developing? Or you want to put the application on a server and allow everyone to connect to it with an IP or a domain name? I think I will want to install it on one server and let everyone connect to it with an IP or a domain name. Because when there is a problem, I don't have to go around updating on everybody's computer. I just update it at a central location. And everybody already, once it's fixed, everybody has it. So this is why cloud is becoming more and more popular and why we are putting applications online most of the time. Let's think about the banks. And let's think about their database environment. If you have a bank account and you visit one branch, there are banks that have over 50 branches. You visit one branch, you expect that they have your data, even though that's not where you opened your account. And at that bank, if you perform a transaction, let's say you make a deposit, you expect the deposit to reflect at all branches because probably someone else is cashing out money after your deposit from a different branch in a different city. If the bank doesn't have a shared or a central data source, it means the transaction you perform here will be isolated and will not reflect on your accounts. And so if someone goes to the bank and withdraws money, another person can go to another bank at the same time and withdraw from the same account because the balance has not reduced. Because of that, we need a shared network where data can be accessed from a central location and data is updated in time. So there are some web applications that share files from a central storage. So in scenarios where we need central storage access, we need to use EFS. Even though we are accessing our application with a virtual machine, EC2, we want the EC2 to get its data from a central source. rather than getting it from a local source. So there are situations where multiple EC2s need data from a central location, and that is where EFS comes in. For content management, multiple EC2 instances access media files like images, videos, documents from a shared source. So with EFS, we are hearing more of shared data source. Data analytics, instances running analytics workloads that need access to the same data sets stored in EFS. Think of the banks and the data they process. Where multiple machines need a shared data source, EFS is best for it. I'm going to play a short clip about the introduction of EFS when Amazon launched it. And let's see how they value this service and how important this service is in the AWS and the cloud ecosystem. Let me share my screen and share this video well.
And it is my pleasure to announce today the Amazon Elastic File System. Which is a managed service to easily set up and share and scale your shared file storage. And so it's a fully managed system to run with EC2. It can manage small applications or really large applications because it scales to a petabyte scale or larger. It's SSD based, so it's going to be fast and have high throughput and low latency. And it's highly available and durable, in significant part too because the service automatically replicates your file system to multiple availability zones, kind of like S3 does, so you don't have to worry about that at all. And then your EC2 instances in that same region, regardless of what availability zone they're in, can access that file system that's been replicated across those AZs in that same region. It's simple. It's really fast to be able to set up and spin up your file system. It is built to integrate with all your existing apps. It supports NFS v4. And the pricing model is simple. There's no upfront costs. There are no commitments. You only pay for the storage that you consume. So it's simple. It's elastic. It allows you to dynamically and automatically resize your file system as you add more files. And similarly, it allows you to shrink when you actually remove files. And it effectively means that you only pay for what you use. So simple and elastic and scalable. Whether you want to use this for an application that's small, dev test, or if you want to use it for something very large that needs very high demands and requirements for scalability, because you can grow Elastic File System to a petabyte scale or more, it handles all of those use cases. It not only scales your storage automatically, it also scales your throughput and your IOPS automatically, so you don't have to figure out how much IOPS you need to provision. And then has low latency, consistent support for thousands of concurrent NFS connections. The preview will start in the summer. We're really excited to let you get your hands on it. If you're interested in registering for the preview, please go to the URL there, which is aws.amazon.com/EFS.
All right. So they previewed this in 2015. And you can see how excited they are about EFS. And I like the part when he said thousands of concurrent connections. Tell me one thing you heard from this video that confirmed what you have learned today, or that was important to you. Tell me something in the chat. Let me see what you put in. I'm going to read a few. So, first person first person by name says, and Carl got it, number one, it's super fast because it runs in SSD. That's good. It's SSD based. That's okay. That's fine. Okello says it's SSD based. Carl says it's super fast because it runs in SSD. Low latency. You only pay for the storage you consume. It grows to petabytes through IOPS. Can be accessed from multiple AZs. So you can see that all of these that we've been talking about, they are exactly what AWS is telling us about this service. Now, we have to understand that this is file storage and not block storage. So although we've had all these nice things like super fast, low latency, of course we want low latency, but if we compare this to EBS, EBS is a different storage service, and EBS is super fast because it is block storage, number one, and number two, it is designed for a single instance. Just like your hard drive is a faster storage for your computer than the internet. You see, the internet is slow, even though we say high-speed broadband. Comparing access or latency between your computer and the internet and your computer and your hard drive, we can't even compare that. The computer and your hard drive is super fast. Think of when you are copying files. You see, when you are copying files on your computer, the way it goes smoothly. But when you are downloading, you see that it takes more time. The same file size. When it's offline, it's faster. When it's online, it is slower. Of course, we will call the online fast. We'll call the network fast. But when we compare it with offline, we can't even compare because offline is super fast. So comparing EFS to EBS, EBS is super fast. Okay, super fast. Okay. So let's continue. Are you learning? Let me know if you're learning. Let me know if you're learning. Somebody is learning. Okay. So please, learning is like that, okay? Especially when you are receiving new information, it's like that. But in the end, you realize that you've been educated, you've understood something, you are better than you were before, you have established a foundation for future learning. Okay, so as you pay attention and you try to connect all the dots, you are learning. All right. So yesterday about EBS, we talked about volume types. About S3, a few days ago, we talked about storage classes. EFS also has some storage classes that we need to take a look at. So under the standard, we have what we call standard storage classes. Under standard, we have EFS standard. Please type EFS standard in the chat for me. EFS standard. EFS standard. Thank you, Ato. Now, this is the default storage class. It stores data in multiple AZs for high durability and availability. It is best for frequently accessed files. Frequently accessed files. So when you are setting up your EFS, you can choose a standard. It's a default class. And it stores data across multiple availability zones. And it's best for frequently accessed. So it's kind of high speed. Then under the same standard, we have EFS 1 zone. EFS 1 zone. Please type that in the chat for me. Now, this stores data in a single zone, AZ, a single availability zone. So although it is standard, a little bit like the frequently accessed standard and high availability standard, this one is limited to one availability zone. And it offers low cost storage compared to the EFS standard because it's restricted to one zone. And it is suitable for workloads where data durability across multiple AZs is not necessary. So over here, you can see that although it is standard, we just want it to be in one zone. So if you really know that this application, you want it in one zone and it's not necessary having it in multiple AZs replicated, then you can go for this to save cost. Then we have the infrequent access or IA storage classes. So we've talked about the standard storage classes. Now we are talking about the IA storage classes. So we have EFS standard IA. Please type this in the chat for me. So you type EFS standard. We also have EFS standard IA. What does IA stand for? What does IA stand for? Who knows it? IA. What does IA stand for? IA stands for infrequent access. That's good. All right. This is low cost storage tier for infrequently accessed files. Like EFS standard, it replicates data across multiple AZs. So this one, although it is IA, it is also like the standard and replicates across multiple AZs. Best for workloads where some data is accessed less often, but highly durable or high durability is still required. Then, of course, we are going to see one zone IA. This type one zone IA. And this one, I'm sure you understand, you've done the math already. This is infrequently accessed and stored in a single AZ. Offers low cost because it's stored in a single AZ. And this is best for infrequently accessed data that doesn't require multiple AZs. So this makes a lot of sense. Now I'm going to play one more video and then I'll talk about the pricing model and we'll wrap up the class. So let me share my screen again.
Lots of applications require shared file storage that can be accessed by multiple computers at the same time. But building your own file storage system takes time and can be very expensive. And once your file storage system is deployed and operational, you have to do complex maintenance and backup operations to make sure it's performing well and your data is secure. What if there was a better way? Amazon Elastic File System, or Amazon EFS, is a shared file system for use with Amazon EC2. With Amazon EFS, applications running on multiple EC2 instances can access your file system at the same time. And the service uses the industry standard NFS version 4 file access protocol, so the applications and tools that you use today work seamlessly. It's easy to create an Amazon EFS file system with a few clicks in the AWS Management Console, or by using the AWS SDK or AWS command line interface. Once your file system is created, EC2 instances in your Amazon VPC can mount your file system and begin storing data in EFS. Amazon EFS manages all the infrastructure for you and automatically scales your file system storage capacity up or down as you add or remove files, ensuring you always have the storage you need while reducing time-consuming administration tasks. And with Amazon EFS, you only pay for the space your files and directories use. There is no minimum fee and no setup cost. Making sure your data is available and secure is really important. Amazon EFS is designed to be durable and highly available and automatically replicates your data across multiple availability zones in a region. Amazon EFS gives you the flexibility to control who can access your file systems and their content. Amazon VPC security groups and network access control lists allow you to manage network access to your Amazon EFS file systems. At the file and directory level, Amazon EFS supports user and group read, write, and execute permissions. And Amazon EFS is integrated with AWS Identity and Access Management to control access to Amazon EFS's administrative API. Amazon EFS lets you run applications that use shared file storage in the cloud and automates time-consuming storage administration tasks, freeing you to focus on your application and business. Getting started with Amazon EFS is simple. To learn more about Amazon Elastic File System, visit our website, and you can create your first file system in a few clicks.
All right, so I hope the audio was loud enough and you heard it, right? All right. And now we can see clearly how this type of storage is designed. You can see how separate it is from EC2. But when we are talking about EBS, EBS is like the storage for the EC2. You can see that this EC2 right here will need storage. This EC2 will need storage. This EC2 will need storage. My question is, what persistent storage is required for this, or what persistent storage service is required for this particular EC2? Who can tell me what AWS service is EBS? Thank you, well done. Thank you. We have also seen that sometimes multiple EC2s need to go out of their own storage and connect to a hierarchical storage space that is or having a file storage structure or a file system structure in specific use cases. This is where EFS comes in. And so in network environments, storage needs can vary. And AWS has clearly provided storage services for every use case. And we have seen the NFS, Network File System, version 4, used in this case as a file system for this storage and as a protocol for the data transfer. This makes it very clear what EFS is. And all that we've been explaining so far, this is a picture of it. Right now, we will take a look at a pricing model of EFS. With EFS, you pay as you go. You pay only for the storage you use. Now, we are not confused about whether it is storage for the EC2 instance or it is storage for a networked environment where multiple EC2s need data from a single source or a central source. So you pay for the storage you use. EFS pricing is based on the amount of data you store and any optional features like throughput or lifecycle management. So once you set up EFS and you store data, The pricing is based on the storage you consume on the EFS system. EFS also provides a free tier, and the free tier of up to 5 GB of storage for the first 12 months. So for the first 1 year, you have 5 GB of free storage, which is perfect for students like you to get started without cost. So although you pay for the storage, if you consume 1 GB, it's in the free tier zone. If you consume 2 GB, it's free tier. 3 GB is free tier. 4 GB, 5 GB. What if you consume 6 GB? What happens? If you consume 6 GB, then you pay. You are charged for 1 GB. Thank you. So lifecycle management automatically moves infrequently accessed files to cheaper storage classes. And so once we set it up, we have storage classes. And depending on the storage class, so the pricing, although it is storage you consume, it also depends on the storage class where you are consuming it, because some storage classes have lower cost. For that, we understand that already. So although you are consuming, the price will be based on whether you stay at Lekki Phase 1 or you stay at Warri, local government 2. It depends on where you live. Whether you live at East Legon or you live at Nima. I don't know the places in Kenya. I'd have said that as well. Okay. What we have left to do before we end the class is to watch a demo of EFS to see how EFS is set up. And the latter part of this demo will show a little bit of Linux configurations. Although that is not required for this exam now, let's watch it for future learning. And before the demo starts, I also play a short intro of EFS again for us to refresh our memories on everything we have studied about EFS. And then we'll watch the demo and end the class right after the video. So let's pay attention and capture every information in these videos. If you are ready, put ready in the chat as I share these videos with you.
As you modernize your applications and transform your business, you need scalable, agile cloud file storage that minimizes your administrative overhead. Amazon Elastic File System provides a simple, serverless, set-and-forget elastic file system for AWS compute services. Amazon EFS is serverless, enabling you to build and run applications without worrying about managing and provisioning infrastructure. And because it's elastic, your file system automatically grows and shrinks as you add and remove files. Designed for the vast majority of file workloads, from latency-sensitive applications to highly parallelized scale-out jobs requiring high throughput, Amazon EFS is ideal for machine learning, web serving, and content management, and everything in between. Build modern applications with AWS containers, serverless, and Amazon EFS, elastically scaling, persisting, and sharing data with zero management required. Amazon EFS is designed for 11 nines of durability, is highly available, and is natively integrated with AWS backup, so your data is available whenever it's needed. It also provides concurrent access for tens of thousands of connections for EC2 instances, containers, and AWS Lambda functions. Plus, you pay only for the storage you use, with no minimum storage requirements. Amazon EFS offers standard storage classes that store your data redundantly across 3 availability zones, as well as one-zone storage classes, which store your data redundantly in a single availability zone. Lifecycle management automatically and transparently moves files accessed less frequently to cost-optimized infrequent access storage classes. Using the industry-accepted estimate that 80% of data is infrequently accessed, Lifecycle management delivers significant cost savings to you automatically. Get started with Amazon EFS today and create a file system in seconds with a few clicks in the AWS console.
All right. In this video, we have heard some key details about EFS. I like the part of 11 nines. So when we spoke of availability and durability, like S3, AWS says that EFS provides the same 11 nines durability like S3. And EFS does not only work with EC2 alone, it can also work with container services and can also work with Lambda. And so, just like we studied about EC2 being direct compute and ECS being containerized compute, EFS can also serve containers as well as Lambda. So let's add this to what we have studied. This particular video is a newer video from AWS, and so you can see the feel of the upgrades that EFS has received. The next video I'm going to play will give us a short demo or a demo of how to set up EFS. Let's watch that one as well, and we'll end the class.
Of durability, is highly available, and is...
My name is David DeLuca. I'm a Senior Storage Solutions Architect at Amazon Web Services. I'm here today to demonstrate the Amazon Elastic File System. Let's get started. Amazon EFS is a simple, fully managed, cloud-native file system. EFS provides serverless shared storage, so you don't need to provision or manage any infrastructure or capacity. EFS file systems support up to tens of thousands of concurrent clients. EFS is elastic and can grow to petabytes in size. You only pay for what you use, and performance automatically scales with capacity. It is also highly available and highly durable. In terms of performance, EFS file systems provide low, consistent latencies and high throughput and IOPS. Finally, EFS offers multiple storage classes as well as lifecycle policies for cost optimization. Now let's move on to a demonstration. Here we are in the AWS Management Console. EFS is located under the Storage category. An EFS file system can be created in seconds. On the main EFS page, simply click Create File System. You have the option of naming it. You then assign it to a VPC and select Regional or One Zone. Then click Create. It only takes a few seconds to be created. The file system is now available and has been configured with the default values. Let's create another EFS file system. This time we'll walk through the customized steps and explain each setting in more detail. Once again, we have the option of naming the file system. You then assign it to a VPC. If you're planning to access this file system from on-premises, be sure to select a VPC that is routable from your VPN or Direct Connect link. Amazon EFS offers the choice of creating the file system using regional or one-zone storage classes. Regional storage classes store the data within and across multiple availability zones. One-zone storage classes store the data redundantly within a single availability zone at a lower cost for workloads that don't require multi-availability zone resilience. This time we'll click Customize to take a closer look at the options. By default, automatic backups are enabled and will create a daily snapshot of the file system. You can also leverage lifecycle management by specifying the number of days that must elapse for an inactive file to move to the infrequent access tier. For performance considerations, most customers will select general purpose. However, certain workloads such as big data analytics, media processing, and genomic analysis may benefit from the max I/O setting. Please note that this setting cannot be modified once the file system has been created. Along those same lines, the bursting throughput mode will meet many customer requirements. This mode automatically scales throughput as the file system grows. You can also select provisioned and specify a fixed throughput in megabytes per second. Your data is encrypted by default. And like any AWS service, you can always add tags to help identify and track your resources. Notice one setting that appears to be missing. You do not specify the size of the file system. It will be automatically created at a minimal size and will expand as needed. Because we selected regional for the availability, EFS automatically created a mount point for all availability zones within that region. This screen gives you the ability to specify the subnet, IP address, and security group for each mount point. Had we selected one zone, we would have only seen a single availability zone on this screen. Finally, you have the option of overriding the default file permissions. The file system is now available. Note that since it is empty, the capacity is only 6 kilobytes. The next step is to attach this file system to a Linux host. I'll be using 2 Amazon EC2 instances. Let's take a moment to look at the EC2 console to demonstrate the integration between EC2 and EFS. We click Launch Instance and select Amazon Linux 2. For this demo, we will keep the default instance size. In the File System section, you can create an EFS file system in just one click. This is the same process that we walked through in the EFS console, and the file system will be created with the default settings. Once it has been created, you click Add File System to Instance to automatically mount EFS when the instance boots up. You also have the option of attaching any existing EFS file systems. Since I've already created 2 Linux instances, I'm going to hit Cancel. Back in the EFS console, let's demonstrate how to manually attach a file system. When you click on Attach, you'll see a couple of commands to mount the file system. Let's copy this bottom one into our clipboard. This is one of the EC2 instances that I created. The first thing we have to do is create a mount point. Let's create a directory called EFS to use as the mount point. Now we can paste the attach command from the clipboard. The file system is successfully mounted. As expected, it is currently empty. Let's download some data from an S3 bucket, just to have some sample files that we can work with. The download is complete, and we now have several files and folders in our EFS file system. A refresh of the console shows that the file system has automatically expanded to 2.99 gigabytes. EFS is, of course, a shared file system. Let's bring up a second Linux instance in which I have already mounted our EFS file system. So now we have two hosts connected as two different users looking at the same shared file system. Lastly, let's demonstrate that file permissions maintain the POSIX standard. In this left window, we are logged in as the root user. If we create a file, we can see that the file has been created with the default permissions, in which the owner has read and write, and everyone else has read only. From the other host, we cannot edit the file, since we are not logged in as the owner. If we change the permission to allow full control for everyone, now the other user is able to edit the file. The takeaway is that EFS maintains POSIX file permissions. This concludes our demonstration. To get started with Amazon EFS, please visit the link to the AWS Management Console shown here.
All right. So in this video, we have seen a lot about EFS, how to set it up, how the classes operate over here. And I like the part of the lifecycle management that you can set up. And once you set it up, it automatically moves your data across the classes to reduce costs. So you can say 30 days, which means that if there is data in your EFS storage space and it has not been used or accessed in 30 days, move it from standard and send it to IA. So the lifecycle management monitors the data and their access rates, and it beautifully migrates them to reduce costs for you. I like that. I also like the part where two EC2 machines are all accessing the same EFS storage. This machine was able to upload something, and we saw that the storage size changed. This machine was also able to access the files. And so this is like a central storage where multiple machines can access. This is wonderful. This is amazing. And as you learn more about managing EC2, you are going to be using command line environments like this to manage your EC2. So when you see someone using this, it means the person is accessing their EC2 and managing their EC2. This has been a wonderful session. I don't know if you have learned something today. Have you learned anything today? Let me see something in the chat. Have you learned something today? If you are watching this video and you've learned something, post in the comments what you learned, like, and follow us for more tutorials like this. Thank you all for watching. Have a wonderful weekend.